as hopefully you can read it up there, bottom right there. I am the manager of the cloud operations and engineering team at Infospace. Infospace is a company, a B2B company in Seattle, Bellevue-ish area that does search, distribution, and aggregation. Pretty interesting, fun problems to solve. Definitely problems at scale. My talk today is on Windows Web Server Management with ASP.NET. This talk was inspired by 2 years ago, my company decided we were going to move to the cloud. And the chief architect and I sat down and we tried to envision what does that look like to move to the cloud. We knew it was going to take a culture change at the company because what you have to do to be successful in the data center is very different than what you have to do to be successful in the cloud. Our infrastructure build-outs were on VMware running in the data center. We were just basically ghosted engineer snapshotting our infrastructure. Every time we needed to build out, we would just create a new instance like that. The cloud, very different. So we started looking at Chef. We looked at Chef, we looked at Puppet, we looked at a couple other things. Chef seemed to be the most widely used and most widely supported product, so that's why I chose to go with that. And we started investigating what does it take to spin up our servers and our services. One thing that we learned very quickly was that there was not a lot of love 2 years ago or a year and a half ago really for the Windows environment in Chef. And so we sought out to try to solve some of the problems that people I don't even think really think about in the Linux world. So I'm going to talk to you guys a little bit from the soup to nuts perspective, like how do you get a Windows web server up and running with IIS and where you can deploy an ASP.NET application using the built-in web deploy tool, kind of what a lot of people are doing nowadays as you're building web applications. On this page right here, I'll also have it at the end, so don't worry about scrambling, is my GitHub. I've posted both these slide notes on GitHub. So this presentation's there right now. So if you just go to github.com/poremland, my first initial, my last name, you can find the slide notes. I've also posted the cookbook. So everything that you're going to see, I'm going to show you guys a lot of code. You don't need to furiously write down any of the code. It's all posted on GitHub. There's some slight modifications. It does work. As of like 2 weeks ago, I think was the last time, I think that's when I finished my presentation, I was using it. So it should be good to go. Hopefully it's helpful. It's open source. Please contribute back if there's other things. I might actually try to make some of it available through community cookbooks. And that's the link right there. So if you just go under my GitHub account, they're both ChefConf 2014 repositories. So the first thing I think we need to understand when looking at Windows Web Server Management with ASP.NET on Chef, or on Windows, is, well, what are the real differences between Windows and Linux? Right now, the cookbooks, they're still playing catch up. Chef's done, or Opscode has done a lot to invest in the various cookbooks, but we're still behind. So there's two things that, as of 2 weeks ago, I didn't see available in some of the built-in cookbooks that I'm going to show you guys how to do. One's writing a lightweight resource provider for doing firewall management in Windows, and another one is for doing web deploy. So you don't get those out of the box right now. But when you leave here, you'll have the ability to do both of those. Chef 11's added a lot of support for things like registry keys, PowerShell, bash scripts, a lot of things that we need. So it's getting better, and hopefully every month that goes by will get significantly better. I'm going to pronounce this word wrong. If you go to dictionary.com and you listen to the pronunciation, it's very different, but I don't know how to pronounce it any other way. So idempotency, I think it's like idempotency, is how I think dictionary.com says it, but idempotency. Right now, a lot of what you have to do in Windows, you have to do through PowerShell or through scripts, which by nature are not idempotent. So you have to be thinking more than the standard Linux developer has to think about idempotency. Very important. I'm actually going to go through in one of our lightweight resource providers, I'm going to show you how to make it idempotent. But that's one thing that you have to be more aware of than your Linux counterparts. And the last one, and you don't run into this often, but you do run into it with Server 2008. By default, UAC is turned on. If you need to do anything that requires UAC to be turned off, that's going to require a reboot mid-run. So you have to think about that, right? A lot of solutions are just create an image that you're going to base everything else off of that has that turned off. But it is important in Windows. You do have to reboot the server more often than you do on a Linux side. So it's important to start with that. Well, before I move on to this one, the last real thing that I'll say is, on the Windows versus Linux world, you can't actually start with a bare bones Windows image and do anything on it from an infrastructure as code perspective. You heard in the keynote this morning that Azure's adding support for doing things like Chef. They're doing that by writing into their agent the ability to basically give it a first run program that will kick it off. AWS does the same thing. You've got this concept of user data. If you're not in either of those two platforms, you're out of luck if you want to just say, I want to take a bare bones Windows image and then bootstrap it. But hopefully after this talk, you'll understand how to do that. You've got actually a couple different options. So the first thing we're going to talk about here is bootstrapping the Chef client. Then we're going to go through and say, what does it mean to actually create the web server? So how do we get IIS installed with all of the things that we need? Then we're going to talk about deploying our web app. So we'll go into how do we write the lightweight resource provider for web deploy. And then I put in here that we'll talk about updating the web app. I'm not going to give you any code because this isn't really a code problem. This is you have to decide your philosophy on how you want to do updates. So let's start with bootstrapping the Chef client. So what exactly does a bootstrap do? It's going to download and install the Chef client. It's going to configure the Chef client. It's going to download your validation key. So this is the way somebody has to vouch for this server with the Chef server, saying that it's allowed to join your environment. So that's what your validation key is going to do. And then if you're doing anything that you want to keep encrypted, like passwords or accounts or access keys, things like that, you're going to probably want to put those in an encrypted data bag. So you're going to need the data bag key as well. And then it's going to kick off a Chef run. So, like I was saying, Windows is not your standard bootstrap. You don't have SSH out of the box like you do on the Linux environment. SSH is the key to bootstrapping a bare bones Linux image. So what do we have? We have WinRM, right? So if you go to opscode.com and you look at any of their bootstrapping code, what they're doing is they're making the assumption that you have WinRM turned on your machine. WinRM gives you a couple things. Gives you the same ability that SSH gives you in that you can run commands that were designed to run locally on the machine. And it gives you the ability to run PowerShell scripts as well. There are some drawbacks to it as well. In Server 2008 and whatever it was before that, 2002, I think it is, or 2003. It's disabled on 2003, and on 2008, I think it's enabled, but it's not configured by default, which means basically for you can't use it until you actually log onto the machine and do something. I think that's changed in 2012, but I'm not quite sure. So the second con really is it leaves a wider attack vector for you open because it's API based, and it gives you the ability to do more. Even though it's a single port that you have to open up, you don't necessarily want the machine sitting out on the internet with this just wide open. So you have to think a little bit more about how to lock it down. On the Linux side, SSH is a proven technology, other than the Heartbleed bug that we've been seeing recently. It's a little easier and a little bit more known how to lock it down. I think in the Windows world, even though WinRM has been around for a while, we still have to be more conscious about how to close down that attack vector. And the last con, which in this presentation is a non-starter, non-factor, because we're going to run a web server. But if you are trying to bootstrap a machine that you don't need a web server on, WinRM is going to require you to have a web server running on that machine. So it's a little bit more overhead for the box that you've got, at least during the bootstrap process. So really, you have no option on an unmodified bootstrap image. So what you really have to do is you have to choose a modified image or use something in the cloud, right? So Azure's got support for it, and AWS has got support for running an agent that will allow you to bootstrap. So the two things that we're going to talk about here first are bootstrapping with the Knife plugin, which is going to require WinRM, and then I'm going to show you how to bootstrap outside of that. So we at my company chose not to have WinRM running because we've got hundreds of servers out there, and we're a little bit more nervous about that technology. So we chose the custom bootstrap option. So we'll walk through what that is. So using the Knife plugin requires, like I said, WinRM to be installed. It does allow you to remotely bootstrap the machine, and it allows you to run Knife commands like you would expect, right? So you want to force a chef run, great. You can do all of that via Knife just like you would expect it. So if we're going with a custom script, it requires you to run some sort of script or executable or something during startup. The easiest way to do that is have some script that is really dead simple, and all it does is download another script. So downloads like a pre-canned PowerShell script or a dynamically generated PowerShell script, which is what we do in our case, which allows us to add a little bit more customization outside of the bootstrap process. We can manage the code for how we want to do that infrastructure separately from the thing that's actually running that bootstrap. So some things that you should think about. I'll give you a handy-dandy little chart at the bottom. One, are you running a web server? Is it going to be on the internet? Think about the security from a WinRM perspective. Second, do you have the ability to host custom scripts somewhere? They're going to need to be able to be accessible by the machine as it's booting up. So it's got to have some sort of internet connection or some local connectivity. Do you need to do something that's not easily templatable? With Knife and the built-in bootstrapping there, you can template your bootstrap process. So there's an ERB file that you can update. You can add a whole bunch of custom code in there. But sometimes there are things that are a little bit outside of your control that aren't easily templatable. Maybe you've got some legacy scripts that you've been running for the last 5 or 10 years, and you need to just quickly incorporate those. So those where custom scripts are helpful. So we're going to look at what does it take to bootstrap with Knife. So you have to prepare your base image, like I was saying. There's your commands. There's 5 commands for getting WinRM installed. Like I said, all of this is on my GitHub, so you can reference it later after this talk. And then you need to update your firewall so that you can allow the WinRM commands to come through. Again, by default, it's not. It won't allow those to come through. So after you've got your base image prepped, that's really all you need to do. You can image it, and then from that point, start there. You need to install on your workstation. You need to install the Knife Windows gem. This is going to allow you to get all the goodness, and then from there, you can update the ERB file and add anything custom into that that you need to do during your bootstrap work, and then you can just run Knife. Notice. In my Knife command there, notice, I'm giving it a role, and I'm telling, I'm going to tell it to boot up with a specific role, and I'm passing my username and password to Knife. Again, that's not super desired. You could possibly work around that. There's another reason why we chose not to use WinRM. So if you want to do it with a custom script, what do you have to do? You have to write a custom script that's going to go ahead and download and install the Chef client, download your databag encryption key. Notice the asterisks. Please do not store your encryption keys in the same place on the same server, because if that server, where the encrypted data sits, because if that server is compromised, they now have all of the data you've encrypted. Just general best practice, but I thought I would bring that up. I've actually seen that done many times, and it's really not good security. You're going to download the validation key next, create your Chef configuration file, and then run Chef. So what does that look like? It's actually a really simple PowerShell. There's not too much to it. You just got to tell it to use no profile and then use an unrestricted access policy or execution policy. And then all we're going to do is we're going to use the web client. We're going to download a string there. So what that string is going to point to is it's either going to point to some canned PowerShell script or some static PowerShell script or some dynamic ASP page or something like that that's going to generate the PowerShell for you on the fly. If you're using self-signed certificates, make sure you add that second piece there as well, or else you'll fail a validation every time. So downloading the files, you can just create a nice PowerShell function. It's going to go out and download a file. It's pretty simple pretty straightforward. We got a function for installing our Chef client. Again, I'm just going to blow through these because all of this code is available on GitHub. This one is more of your one of the key components. This is where you're creating your client.rb file. Notice there are a couple things that I've bolded in there. You need to give your node a name. And so if you're dynamically generating the script, when you make the request for the script, you should probably give it some unique name. Like in AWS where we sit, we give it the instance name. So that way it's always unique. And you want to put that in there. And then you want to obviously make sure that you're pointing to the correct Chef server URL. But pretty simple, you're just going to write out that to a client RB file. And then you're going to create a function that will actually run Chef client. All we're going to do is we're going to use the built-in PowerShell start process, and we're going to start the Chef client with the arguments. In here, what I'm doing is I'm telling it to start with a specific role. Again, this comes from a dynamically generated PowerShell page. So when you bootstrap the machine, you can tell it, hey, I'm bootstrapping a MongoDB server or a SQL server, or I'm bootstrapping my web server or whatever. That'll just get dynamically put in there. And then an environment file for any other specific things that you're overriding or doing in your Chef run. Put it all together, it really comes, those functions just come down to running these 6 lines right here, where you download it, you install it, pretty much everything I just walked you through. So at this point, sorry that I've taken up a fourth of this talk just talking about bootstrapping, but unfortunately we live in the Windows world. What you should do is you should write Windows. You should send them lots of emails. What's that?
I said you would have saved me 2 days.
Yeah, so it actually took me a week, I think, to figure most of this stuff out. You should email them and ask them, hey, we really want to use your product. We want it to be better. Please, do something like make SSH or WinRM available just out of the box base images. So now we're getting to the meat of this talk, right? So we want to create our server. So what does it mean to create our server? It's actually a pretty simple 3-step process. We're going to create IIS, or we're going to install IIS. We're going to install .NET. We're actually going to install some additional .NET stuff. .NET comes by default on Windows 2008 and above. And then we're going to install web deploy. So for IIS, there's really 2 things we need to do. We need to create a feature list. And this will make more sense in a second. But when you go into Windows and you say, I want to install roles or features, this is that list of roles and features, so we can do it programmatically. So really, the easiest way to do this, what I found, is in your cookbook's default.rb file, or default RB file under attributes, you can just create an array, right? So I've named this one IIS feature list. And in there, I'm installing features like the IIS web server role, the web server, things like HTTP redirect, right? Things that you're going to need, IIS, ASP.NET. From my perspective for this cookbook, if you use my sample cookbook, the ordering is important because features will fail to install if other features haven't been installed first. This list will work out of the box, and this will give you IIS that is able to do ASP.NET. So after we've got our features, we just need to create a real simple recipe to install those features. The reason I put them in an array is because that makes my recipe dead simple. I can just iterate through that array and then use the feature provider in the Windows cookbook. Everything that you're going to do right now is going to require you to use the Windows cookbook and most likely the IIS cookbook as well. There is a lot of development going on in those cookbooks. There's new features being added all the time. So right now we're just going to use out of the box the feature provider, and we're going to install each one of those features. So pretty simple, right? Hopefully everybody feels comfortable doing that. The next thing we're going to do is we're going to install .NET. Installing .NET really is a 2-part process. I'll take questions at the end. Installing .NET is really a 2-part process. We need to register .NET 4 with IIS. This is going to give us the ability to run ASP.NET through there. And then since we're writing modern software, we also need to install .NET 4.5. So looking at our register ASP.NET recipe, it's pretty simple. All we need to do is, I've got 2 variables that just make it easier to get to the path for the ASP.NET reg IIS executable. And then really what we're going to do is we're just going to use the execute command. By default, this execute command is not idempotent. In this case, it doesn't really matter because we have built-in idempotency. This command will have the same result no matter how many times you run it. So I didn't do any work to make this recipe idempotent, but it is important to recognize that the execute command is not. And so again, like I said, as Windows Chef developers, we are constantly thinking about that as we're writing our recipes, because we don't want, God forbid, we put our servers out in the wild and they start rebooting and dropping connections, or they recycle app pools, or they do things because we forgot to add idempotency. So the next thing we're going to do is we're going to install .NET 4.5, and again, it's very much the same way, except for we're going to use the package provider in the Windows cookbook. Hopefully you guys are all pretty familiar with Chef, but one thing that you'll notice is you'll see the cookbook name and an underscore and then the provider name. That's pretty simple. It's pretty simple convention that's used there, but it's also a good way as you're looking through other people's code that's been posted to figure out where this stuff is if you want to look and see how it works. So here again, we're gonna tell it to install that Windows package that we've downloaded, and we'll go through that in a little bit. And then the last thing we need to do is install web deploy here. So web deploy is again another executable. We're just going to download it using it as a Windows package. What this is going to do is this is going to give us some of the built-in what a standard .NET developer would expect, right? You're writing a website. Microsoft suggests you use, or they encourage you to use web deploy to build your projects for simple deployment. It's a separate executable, but it's pretty dead simple to get installed. So again, we're going to use the package provider on the Windows cookbook, and we're going to get web deploy installed. So at this point, we've actually got a web server that's running, that's up and running, that's been bootstrapped. It's got IIS installed, it's got ASP.NET installed, it's got IIS registered and set up. It's really now just customizing it to run our app, right? So what do we need to do? It's really a three-step process to get your app installed. The first thing we need to do is we need to make some firewall rule changes, because again, out of the box, the machine is completely locked down. As of, like I think I said 2 weeks ago, maybe in the last 2 weeks it's been there was no lightweight resource provider that would give you the ability to do this firewall, so we're going to write one today. So writing a lightweight resource provider is pretty simple. You've got the resource that you have to define, and then you've got the implementation that you need to define in a provider. So what we're going to do here, I'm not going to go over everything, but what we're going to do here is we're going to define our LWRP with just an add action. And we're going to give it a bunch of attributes that we're going to use in our provider. The next thing that we're going to do is we're going to actually write our implementation of our provider. So what we've done is in our resource, we've defined the add action. So in our provider, we're going to implement the add action. That's really all we have to do. One thing to notice there is I've got this nice if-else block. This is what's giving me the idempotency in this case. So the first thing I'm going to do is I'm going to check, and I'll show you on the next slide how this magic kind of works, but I'm going to check on my new resource whether this attribute created, which I've defined down in that yellow block right before the initialize method, whether this has been set to true, right? And if it's been set to true, then I know that I don't need to do this again, and I can just kind of go about my merry way, and the expectation of what is going to happen here, whether it's been installed or not installed, is exactly the same. So it gives me that idempotency. In the else block, if I do need to do the work, all I'm doing is I'm building up a netsh command. It's pretty simple. I like to break them up into their logical pieces. So we define our firewall rule just like we would call in the command line, and then we shell out that command. And that's the reason we need to add in the idempotency, right? If you try to do this twice, you'll get an error the second time. So you want to make sure that you don't run this over and over again. So how did we get that beautiful, really easy one-line if statement to work? We used the load current resource method that's already defined for us by Chef. If you override this method, it will get called before it actually tries to call the action in there. And so all we do in this method, again, is we use netsh, and we just check to see, has this firewall rule already been set, right? So what I'm doing is I'm asking netsh to show me the rule, to show me that rule with this given name, and if it's there, then I set the created attribute to true, and then when I check it on my action, it's set to true, and I know I don't need to do anything. So that's actually all it takes to build a LWRP. Again, this one probably took me a while to figure out. Hopefully that's demystified it a little bit for you. LWRPs are actually really easy, and I encourage you guys to try to write them and try to contribute them back to the community, because there are other people like you guys that are trying to navigate the world of Windows and Chef that can definitely benefit from the goodness of community contributions. So the next thing we're going to do is, now that we've got web deployed installed on the machine, we're going to write a web deploy LWRP. Again, I use the sync action, or I named my action sync because that's what web deploy uses for its verb. So I figured that's what a standard Windows developer would expect here. And again, I just do my sync implementation in the provider. For this one, I don't really need, well, you should add idempotency, but in this case, I didn't add the idempotency in here because there's a larger question on how do you want to do updates, really. So it's actually kind of overcome by design. And we're just going to, again, use the execute command at the bottom to run our command that we've built up. So we've got our firewall rule. We've got the ability to change firewall rules. We've got the ability to do web deploys. So how do we actually get our app installed? The first thing we need to do is we need to create a recipe that will deploy our app. So we've got, the first part is creating an app pool. So we're going to use the pool provider that's in the IIS cookbook. And we're just we've got a couple attributes that we'll define here, things like our web app's name, things like, well, in the next couple slides, I guess we'll say that I truncated the word. I guess it's the runtime environment in there. So we just create our app pool. And actually, one thing to notice there is in my actions that I'm going to have it run, I'm actually going to have it stop the app pool. And the reason being is because I don't want it actually in there. If you're doing this in an automated fashion, you don't want the app pool up and running if you have any checks that are saying like, hey, can this thing serve requests? It can't serve requests if there's no app pool running. So you want to stop that after you create it. The next thing we're going to do is we're going to create an IIS site. So the first thing we're going to do is we're just going to make sure that the directory exists. So again, we're using our web app name for the name of the directory. And once we know that the directory exists, we're going to use the site provider in the IIS cookbook, and we're going to actually just create that IIS site. It's pretty simple. So the other parameters that we're defining are things like the port that the site are going to run on, and really just the name in that case. So after we create the site, we're going to start the site. And then we're going to use our lightweight resource provider for the firewall. Now that we've added that lightweight resource provider, it's actually pretty dead simple to use. You just preface it with your cookbook name _firewall. So in this case, it's your _cookbook. And then we just say we're going to add a firewall rule to allow TCP in on the ports that we've defined in our attributes file. And at that point, we have a nice firewall rule. The next thing we're going to do is actually deploy our app. So this is where our web deploy lightweight resource provider comes in. The first thing we're going to do, again, like we did with the site, is we're going to make sure that the local directory exists. I have chosen, in this example, I have chosen to package my web deploy zip file up into my cookbook. And the reason being is it was just more complicated to download it from the internet, and it made a much easier presentation. I don't know that I necessarily suggest this, but I don't think there's anything wrong with it, especially if you're versioning your app. So because I've included this, and in my sample cookbook that I put on GitHub, there is a sample Hello World web deploy app that's included in the cookbook. I need to copy that file from the cookbook into some known place on the file system. So what I do is I just put that into a local directory, and then I'm going to use my web deploy, and I'm going to tell it to install that package and pass any parameters that I've defined in there. So now I've got a server that's running IIS, it's got ASP.NET installed on it, it's got firewall rules that have been set to allow my application to talk. My application's actually installed, so the last thing we need to do is just start our app pool. So we've started our app pool using the pool provider in the IIS cookbook. And at this point, we actually have our server out and running. It's ready to take traffic. It's ready to serve requests, and we've got all of our really great application goodness out there. There's a couple things you can do to simplify this, though, as you're moving forward. So the first thing is, if you want this to be consumable by other people, so that maybe you're writing a an ASP.NET web app that you want to just open source and you want it to be like, hey, if you guys want to just install this on your machine, you want to make that dead simple. So the easiest way to do that is to create a default RB file in your recipes folder. And what happens is when people say that they want to run that recipe, or they want to run that recipe with your cookbook name, it goes to this default.rb. And so you can abstract away all the implementation details of the different steps that you have to provide, how what order they have to run in. All they have to say is, I really want your app, right? So they just define that. And they do that by just saying recipe and then your cookbook name in there. And so what this really does is it gives you the opportunity to get people to easily adopt this great new awesome open source thing that you're putting out there. Or if you're working with customers that are trying to integrate an app, it gives them one line that they can include to make it easy. So I would highly suggest doing that. And then you can also, if you do that, you can also utilize roles a lot easier. So you can define these role files in the Chef server, and it makes them dead simple. Role files, you can version them. People suggest, in fact, when we talk to Opscode, they suggested we keep as much out of the role file as possible because you have to think about versioning these. They're not versioned by default like your cookbook stuff is, but you can, using the knife command line, you can actually export them out and then check them into your Git or your SVN repository or whatever, but you have to remember to do that. So again, following their advice, we've kept this very, very simple. We've defined the name, the description, and really all we've done is we've said, hey, for this role, for our web server app, all you need to do is run the recipe for our default recipe for our cookbook, and everything will just happen automatically. And so as you need to spin up new roles or new servers, you just give them this role and they're good to go. And in fact, in our Bootstrap, that's what we were doing. We were saying role, my app or whatever, and that's really what this file here defines. So where do we go from here? The last major point that you have to think about is really, how do I update my application, right? This is, again, where as Windows developers, you're probably thinking about this a little bit differently than the standard Linux LAMP stack is, because anytime you update the code in ASP.NET, it's going to recycle the app pool, especially if you touch things like the web config. If you're doing that on live servers, you're going to drop whatever connections you've got to that server, and you're probably going to take some connections that are going to time out as your app pool spins up. So what you want to do is you really want to, before you actually start doing this deployment, you actually want to just think about how are you going to roll this out, right? Are you going to use something like blue-green deployments? So where you're saying, I've got my current server that's out there, I'm going to spin up another server that has the new code, and the moment that's finished, I'm just going to swap them. Right? So I can continue to serve traffic the whole time until I'm ready to serve traffic on the new stuff and swap those out. That's actually what we use, and we found it to be pretty helpful and pretty easy, especially in the cloud when you're managing hundreds of servers. A lot of people also will do rolling deployments. So the way the rolling deployments work is, you go out and you just iterate over your machines, and then you pull one out of your VIP or out of your load balance or whatever, you update it, you put it back in. That's a little bit more difficult, and simply because you have to ensure that both versions of the apps can run simultaneously side by side at the same time. Sometimes that doesn't work, right? Sometimes you make a schema change in your database, or you've got a contract with some third-party API, and that schema's changed, and once you start requesting one, the other ones are going to break. So these are really, really the important things to think about. For us, what we've done at InfoSpace is we've taken the route of creating immutable Chef runs. So we don't run the Chef client constantly, and the reason is because it makes it a little bit harder on Windows. So what we do is we do an immutable Chef run, and we'll spin up our server. Since we're in AWS, we're dealing with AMIs. We'll create an AMI from that, and that's what we build everything from. The next time we have to do a deployment, we'll then re-go through that process. We actually follow that model from Netflix. In the cloud, they're actually running Linux stuff, but they call it their bakery. And it's worked pretty well. We've actually been able to cut our deployment down, I I think we're in under an hour, and that includes building the servers in AWS, so like actually spinning up the Windows instances. We're trying to cut that down to just like 1 minute over top of whatever that instance creation time is. So right now we're about 25 minutes over top of that, but there's a lot of ways we can get around that. So at this point, I think I've got like 3 minutes left, so I can take some questions. I also want to let you guys know, I think it's the Marina Room. Hopefully I didn't say that wrong. But I'll be doing office hours today from 4:15 to 4:35. So feel free to stop by if you're not comfortable asking questions in a larger setting. And then again, I've got my GitHub page. Actually, I'll put this one up there. I've got my GitHub page up there. I do have a blog, and I try to do at least one post a week talking about various technology issues, and then some links to things like blue-green ones.
For your web server swap, do you do any warm-up or validation?
We do. So that's actually part of the last thing that we do in our chef run is we hit what we call our app validation page, which it serves two steps. It starts the app pool for us, which will then go through and do the warm-up basically. Or we'll go through and make sure that everything's sitting in memory, it's all JITted and all that kind of stuff. And it will actually make a request, so it does a pretend warm-up. We don't have cached content because of our contracts with a lot of our third parties, so everything's stateless in our system, so we don't have a long warm-up period. It's really just loading all the objects up. But I would suggest thinking about doing that as the last part of your chef run. And in fact, what we found is it's super helpful. We can catch some things at that point that maybe the machine didn't start up correctly or something before it actually goes into rotation in our load balancers.
You are probably not going to have time to go into it too deep, but how do you test your cookbooks on Windows guests?
We're manual testing right now. We are trying to figure out what that is, what that looks like right now. I think there's a project called Test Kitchen,
which doesn't support Windows.
Yeah, which doesn't support Windows, but we were gonna try to look at that. So right now, what we're trying to do is we're trying to put some of our stuff in just Ruby libraries, and you can use spec at that point to test them. But we don't have a whole lot of testing going on with our actual cookbooks. So we actually stage everything before we deploy it, and that's where we catch a lot of that stuff. Yeah, sorry.
What about running your services and app pools under a different user, or what about doing all this from your TFS build server?
I don't know about the TFS build server. It should be possible. We do all of this from Jenkins, and so we've got a Jenkins process that's set up that because we're in the cloud, since we're in AWS, we can use things like SQS and SNS to allow some asynchronous distributed talking on during the build out process. But you should be able to do all of that with TFS, and I think we've used cruisecontrol.net in the past for some of that stuff. Was there a second part to that question?
Yeah, and running everything under different users.
Oh yeah. So my examples here are pretty bare bones, but you can do. You can script your LWRP so that you can add some of that functionality in. We have some additional stuff that's proprietary to what we do with the app pools as well. So you should be able to take that app
You
pool.
found it covers all the app pool manipulation.
Yeah, because you can do it all from the command line. Windows does provide you, they don't make it easy to find, but they do provide you command lines for all of that stuff. And if you can do it via the command line, you can do it in Chef.
But then you're not using the IS cookbook, for example, for the extensive application pool reconfiguration?
For app pool stuff, we actually we've extended the IIS cookbook and we've built on top of it because there are some things for app pools. I'm trying to think, what are some of the specific things that we do? There's some, actually this is more for web deploy, but there's, when you deploy your packages, you can tell it to exclude certain things like different configs or things like that. So we have some extended functionality on that we use. But what we've done is we've just taken the cookbook, we've forked it, and then we've added some proprietary extensions on top of it.
I think the app pool identity is part of the IIS cookbook, though. I think that is an attribute of it. I mean,
it is, but there is, I cannot remember off the top of my head what it is, but we've had to extend something around.
Maybe the physical path, that's not working, I think. But you have to, the physical path is not being used. If you want to change it, it's not working.
The path on to your
file.
Yeah,
where it is located.
It should actually, because when I did mine, I was copying it to a local place, and that was just out of the box. I don't think it worked in 10 or 11.4. the Chef 11.4, but I think with the latest version it does.
When you made a decision to,
Sorry. I can answer the last question.
when you made a decision to go with the cookbook over the PowerShell version and just calling the PowerShell modules, was there a reasoning behind it?
You're talking about for the bootstrapping?
Or just for manipulating IIS and doing all that work?
Yeah, so I'm not a super big fan, this is me, I'm just not a super big fan of writing a whole bunch of production code in PowerShell. And it's just because it's a little bit harder to test, it's a little bit harder to catch a lot of those errors, because it is a scripting language. And so I try to favor using some of the built-in things. Like I always ask my team to ask themselves, what would a standard think of? So in this case, what would a standard chef developer expect, right? And so a standard chef developer would expect something in a recipe or provider over something in a PowerShell script. And so that's what we should default to, because as we hire people, we're gonna hire people that have knowledge and understanding of the environments that we're in. And so we should try to build our environments such that that standard developer would be able to intuit or expect it. So it's just a personal preference. Cool, thank you guys, I appreciate your time.